In this video, we will talk about a histogram. So far, we have used this kind of graph to show all the measures that we have made. For example, if we had a set of measurements for children's knowledge of letters, that is, how many letters children know the sounds to or their names, and so for each child, we have a number of how many letters they actually know, like this. This means that there were two children who know two letters, three children who know three letters. There weren't any children who only knew four letters. There were five children who knew five letters, one child who knew six letters, and so on for each possible value of number of letters known. This kind of graph has a lot of information, but is not very informative if you want to get a sense for the distribution of your data, especially if you have very large samples or very many different possible values that your observations could take. So this is another example where we have measured a bunch of children on their reading skill with a word reading fluency test and calculated a words per minute metric for each child. So there was one child who couldn't read at all, so got a 0 words per minute, and there were two children who got 20 words per minute, and so on. Because there are many different values, this graph is quite flat. It doesn't really tell us how the measures are distributed. And you can imagine if we had 500 children, this would not look very interpretable. Instead of showing every single value we obtain, what I do instead is put ranges of values in buckets. Buckets are called bins, and bins are formally defined as consecutive non-overlapping intervals. So that's ranges of values that touch on their ends. So for a bin width of 5, the first bucket, the first bin, would be from a value of 0 to a value of 5 words per minute. So how many children had reading rates from 0 to 5 words per minute? Well, 1, 2, 3. So these 3 children go into the first bin that represents values between 0 and 5, and there are 3 values inside this bin, this bucket. The next bin would be between 5 and 10. So 1 here and 5 here, that is 6 values were observed between 5 and 10, and this is our second bucket that contains 6 measurements. And so the next one would be between 10 and 15. We have only one child with a rate of between 10 and 15 words per minute. So this is at 1. We have 2 plus 3 plus 2 plus 2. That is 9 values in the range between 15 and 20, and so on. Now, one important thing here is what happens with the border values. We should not count them twice because the total number of observations here must be equal to the total number of observations here, which is how many we have. So if we count the heights of all these bars, the sum would be how many children were assessed. So it's important to be consistent. Usually, the border value goes on the left. So 20 words per minute goes into the 15 to 20 box and not into the 20 to 25 box. So 5 words per minute would be here, 10 words per minute would be here, and so on. And the result of this binning of values is taking this representation of which is called a frequency plot and creating this here, which is called a histogram. The histogram is probably the most important graphical display there is. We always use it when we have quantitative variables because it gives us at a glance a very good indication of the shape of our data distribution, how our data are distributed over values in a way that is not so much affected by how many values there can be or how many measures we have made. And we can also easily see if there are peaks, if there are gaps, or if there are any outliers far from the other measurements using the histogram.